let me just say that this is definitely more difficult than the first two tests we had. So on module 3, unit 3, chapter 3, 12 modules. There should be closed notes and parent proctoring it. So that's a matter of just defending between you and the Lord, and maybe your parents, of course. So, and it's due next week. Yes.
From my understanding, can we write some of these definitions on the back? Because there's
yeah, if you don't, I understand. There's like ABC. Yeah, there's 7 of them. I would do them on the back, on the bottom, but probably on the back is fine, or an attached sheet of paper will be fine in this case. Don't forget that anyway, they put enough said on that. So, any questions about that, about taking the Model 3 test? It's a take-home test, but typically take-home tests are, when they make them, I never do that myself, but just like, but what typically they're more difficult than what you take, you know, here. That's cool, yeah.
Do we need to bring them back next week, or
Yes.
can we just like email you?
Bring them back next week. I don't want to email, yeah. I get enough email this stuff. Okay, put these together. Get these graded. All right. Now, we're going to look at a little video on the, I'm going to pull this back so it's bigger. Yeah, I want it as big as I can get it. Okay. There's a, we're going to watch a video about the properties of water. Water, what's the, you guys know the chemical formula for water, what is it? H2O. That means every oxygen atom, if here's an oxygen atom, has a couple of smaller hydrogen atoms attached. And they're like this. They're not like in a straight line, carbon dioxide is, but it's like that. What happens is, water is sitting here, its outer shell, it wants to get 8 electrons. Electrons, it looks like this. It's got 2 places, it just needs 2 more electrons to fill that outer shell. Hydrogen, on the other hand, just has 1 electron, which it will give up to fill that shell. So they end up sharing it. It's not like it gives it up, but they share it. But this guy said, I'm just going to get rid of it. And this guy says that just as soon take it. So this guy has a stronger pull on it, the oxygen atom does, than the hydrogen atom. This is oxygen here. So because of that, the electrons are attracted more to the oxygen atom than to the proton. So this tends to have a negative charge. And these tend to have a positive charge. So one side of the molecule has a negative and the other side is a positive. That will have to do with the second lab we do today. The first lab is based on the formula, H2O, with a little electricity in an electric field, you know, where there's electrons moving through it. You have to break this down. And it breaks apart to form hydrogen gas plus oxygen gas. By the way, this should be in your notes. It turns out you have to have 2 water molecules to do this. So if you count the number of atoms on each side, 2 water molecules, each one has 2 hydrogen atoms, so 2 times 2 says, you always want to do this check, 4 hydrogen, 2 water molecules, each one has 1 oxygen, so that means 2 oxygen. Let's take a look over here. 2 hydrogen atoms, 2 hydrogen molecules, each molecule has 2 hydrogen atoms, so that's 4 hydrogen. 1 oxygen molecule, but that oxygen molecule has 2 oxygen atoms. So it's the same. And that's important. It's called balancing it. It's kind of like balancing equations in algebra. You guys are, most of you are taking probably algebra 1 now. And you're balancing, it's a similar balancing equation so, that you do there. At any rate, split apart. When you use electric current to cause them to split apart, the hydrogen atoms end up giving up an electron, giving it a positive charge. This oxygen atom over here collects those two electrons, giving it a double negative charge. So if you've got a battery, and the battery has a positive charge and a negative charge, what do we know about opposite charges? What do you guys know about opposite charges? Yes?
They push away?
No, they attract. Opposite charges attract, like charges repel. So what happens is, you've got a positive terminal and a negative terminal. The oxygen atoms come over here and collect there. The hydrogen atoms come over here and collect there. Now they end up being H2 hydrogen gas. When they come here, they collect some electrons from the negative terminal, turn them into hydrogen gas, which escapes. This one gives up the electrons here, turn into oxygen gas, which escapes. So what happens is, at the positive terminal, you find oxygen. At the negative terminal, you find hydrogen. Now, which one, are you going to have more of one gas than the other? What do you think? Looking at that equation up here. Is there going to be more of one than the other? More hydrogen, twice as much. Even though you don't see it, just like in algebra. If there was no coefficient in front, we assume a 1. If that was like an x or an x squared or something. And so, water breaks down to form 2 hydrogen and 1 oxygen molecule. So twice as much. If we do this right, you will see twice as much water collected. So let's go ahead and watch the video, and we'll see if we can talk about it anymore.
It might just be the most universally known fact in chemistry, the chemical formula for water, H2O. A model of H2O doesn't look like much. 2 small atoms of hydrogen, H2 part of H2O, attached to 1 bigger atom of oxygen, the O part of H2O. The cartoon drawing of the teddy bear. And actually, water is kind of funny. Fun fact, water, H2O, is the only natural substance on Earth found in all 3 common states of matter: liquid, solid, and gas or vapor. It's also one of the only common substances that is less dense in solid form than in liquid form. And water can dissolve more substances than any other liquid. Let's focus on H2O in liquid form. What gives water its remarkable qualities and abilities? It's all in the molecule's content and structure. Not just what each H2O molecule is made of, but how the atoms are positioned, in what configuration and shape, and how they are bound together. In water, just so we'll know for later, the H's and O's are held together by covalent bonds, by sharing electrons. H2O is a polar molecule. The same way our planet has north and south poles on opposite sides, the H2O molecule has 2 poles on opposite sides. And like a magnet, H2O has 1 positive end and 1 negative end. Thinking of that cartoon teddy bear again, the chin side of the oxygen atom has a slight negative electrical charge. The opposite side, the side with the 2 hydrogen ears, has a slight positive electrical charge. This might just be the second most universally known bit of chemistry. Opposites attract. The positive hydrogen side of every H2O molecule is made to attract and be attracted to the negative oxygen sides of other nearby H2O molecules in all directions. More and more of them pull closer and closer together until they're like people in a hot, crowded dance club. Packed so close together they can hardly move, but still turning and moving wildly. Molecules that stay close to each other are called cohesive, and water is highly cohesive. A pentillion, even hextillion of chaotically moving, tightly packed H2O molecules cohere to make a single raindrop. As good as water molecules are at always cohering and convening, they also form bonds with surfaces and molecules unlike themselves, a force called adhesion, as in adhesive. Pour the water out of the glass, and the inside of the glass is still wet, Some H2O molecules stick or adhere to the silicon molecules in the glass. Being cohesive and adhesive is what makes water a weird universal solvent. How? Take salt or sodium chloride. Sodium ions, abbreviated as Na+, and chloride ions, abbreviated as Cl- in a crystal. As soon as a salt crystal hits the water molecule, it's crushed by the molecular mob of H2O molecules that break it apart, separate the sodium chloride ions, kind of a chemical divide and conquer. Because sodium ions have a positive charge, each one is swarmed by H2O molecules flying at it with their negatively charged oxygen sides, completely surrounding the sodium ion, isolating it, carrying it off in a turbulent sea of H2O molecules. The same thing happens in reverse to the chloride ions, which have a negative charge. Each of those is surrounded and isolated by H2O molecules leading with their positively charged hydrogen sides. Each salt crystal is broken into tiny pieces, dissolved by and into the water. There's much, much more to know about H2O and how it works to keep every living thing on the planet and the other planets alive. And this video is a drop in the bucket.
I think that's it. I thought there was. I don't need to do more. Okay, so I think that's. I'll leave for now. Let's turn the light back on. So cohesion and adhesion. Cohesion means to kind of stick to each other, stick together, and adhesion means to stick to something else. Like if you have what's called a graduated cylinder in chemistry, and you fill it up with water, it doesn't make a nice straight line here. It does this. It sticks to the sides here. And on a surface with a bubble of water there, it kind of goes like that, right? It sticks to itself, makes it kind of do that kind of thing where it bubbles up like that. Yes?
As you pronounce adhesion?
Adhesion, A-D-H-E-S-I-O-N, and cohesion. So this is adhesion sticking to the sides. And so you have to explain to students that when you want to see this level here, don't pick that point, you pick this point right here at the bottom, meniscus it's called. And so that's just one of the properties of water. So what we're going to do is, by the way, we only provided 4 test tubes here. They needed to provide 6 for 3 groups. So we have, one group is going to use these larger ones. What you're going to do is, you're going to take this into your bathrooms, fill this up with water to the very brim. You're going to fill this up about 2/3 because you're going to put one of these 9-volt batteries in here and it's got to cover it. So it's going to be close to the top, more than 2/3, about 1/4 of an inch from the top. Half an inch would probably do it. Half an inch from the top will do it. And you're going to put this in here, and you're going to put these on top. Now, they aren't going to balance there, so we've got to hold them. And what you're going to see happen, now, by the way, the water you put in there, you're then going to, here's my Epsom salts. I have a couple of, I think I'll just put this on one of the side tables. Take a couple of tablespoons or a couple of these teaspoons. A couple of heaping teaspoons is more than enough when you stir it in. So half inch from the top is all you want to really get a mess. That'll make it, we think of water not conduct electricity, well it does. You guys ever see, years ago it came out, I think it was Mel Gibson in it called Women Want, where he falls into a bathtub and he's got, his hair is, he's in the bath and he tries to get out but he can't. When the hair dryer falls in, he gets electrocuted and then suddenly he can read women's thoughts. It's kind of crazy. But he gets electrocuted by this. We don't want to be playing with a hairdryer while we're sitting in the bathtub, right? That would be silly. Water does conduct, but not nearly as well as when you add salt to it. So when you add, this time instead of using table salt, we can use Epsom salt, it works real well. And you will see, once you've added the Epsom salts, you put that battery in, you'll see bubbles coming out both terminals. Okay? This is the positive terminal. What do we expect to collect at the positive terminal?
Oxygen.
Oxygen, because, let me make this a different color so it really stands out together. Because oxygen charge is trapped. And the oxygen will have a negative charge. So it's going to be going to the positive terminal, which is a smaller one here. And the wider one is a negative, and hydrogen will be collected there. We expect to collect twice as much hydrogen as oxygen. So at this bigger end, we expect it to go up. It's going to be filled with water, and you expect to see the difference, you know, as the gas collects, twice as much hydrogen gas as oxygen, pretty close. That'll be so cool to prove that water does have the form of H2O. You were going to verify it. And that's all there is to it. Questions? Okay, when we come back, if we have time, what time is it? Which we might. What you're going to do is you're going to take, I don't know which one of these cups, I also have these that work. You're going to take this and fill it up with water, punch a hole in the bottom. You need to make it with a little pin, you know, the kind of pencil work. If it's not quite big enough, make it a little bit bigger. And water's going to drain out. We'll use that bucket to let it drain in. And then you're going to take a comb. I don't use a comb, I don't know why. See if I need it. See how I just buff it up, shine it up really nice. And, yes, you have a question?
Will we be running a lab report on this?
Good question. I think you do on the first one. Let's see. Do experiments. Did not say that. So I guess we're not. No, we're not.
Yeah, I don't think we're writing a lab report the week we just did and this week.
Right.
It's on regular.
And the reason that is when you're taking tests, they don't want to make you, because you'll be taking this test. So I think that's what they're thinking. So anyway, you're going to put water in here and watch it dribble through. You run a comb through your hair and stick, the teeth near it. You will see it attracted to it. Now, if you have a glass rod, like these test tubes, and you rub them on cloth, and bring it near the water, it'll also be attracted to it, not repelled, because the comb has a negative charge. So all the water molecules orient themselves like this, and they're attracted to the teeth of the comb. Now, interesting. The closer you are, the stronger the attraction. So is the positive and the negative end, which one's going to be closer to the comb?
Positive.
The positive. So there's a stronger positive attraction to the comb, negative. This comb has, lots of free electrons, so it's got a negative charge. Then the repulsion by the negative end, oxygen, is weaker than the attraction to the positive. So it's attracted to it. But if you bring a glass rod in here, which has a positive charge, it flips around. It's over here, and the attraction of the negative side to the positive charge of the glass rod is stronger than the repulsion. So it's attracted both times. At first when I did this, I just, as a teacher, I thought, okay, I'm going to do it with the glass rod. You never have to do it with the glass rod. And I thought it would be repelled. It was attracted, and I had to think about it. The water can move around and orient itself so that it'll just spin around, and the attraction is stronger than the repulsion again to the positive charged rod. So if you have time, you can try just taking your test tubes and on the cloth and see if that works. Yes?
We fill the test tubes with water, right?
Yes, you're going to fill the test tubes up with water to the brim, but you do that afterwards. You're going to fill this up to a ½ inch from the top, bring it back, stir in some Epsom salts, and then you're going to put this battery in there, and then you're going to fill these up to the brim. Hold your finger over it and put it until they're submerged under the water. Then you can release it and do it. You don't want any gap in there, so you hold your finger over these. So no water escapes. Do your best to do that. Get it in there, and then you can place it over the battery. So it's a little bit of, you guys can work that out. So here's one group right here, which you need. And the other groups are, go ahead and get your stuff, get your glasses. The other two glasses are here. They're all about the same height.